Okay, good morning everyone. Let me talk about my project airsight AI. The problem is air pollution kills 7 million people annually, and yet most of the world lacks real-time PM 2.5 monitoring. So here is a solution for that. That it provides. It's a forecasting platform that uses satellite data available and with the combined XGBoost machine learning to predict air quality for 24, 48, and 72 hours. Okay, so first we had done the data extraction from the satellite data that using GEE, Google Earth, and then uh, we made a data pipeline. We did feature engineering, and then we used our model XGBoost training, and of course made the dashboard for this, and showed here the complete data. Uh, Talking about how it works, of course we had done interpolation. Monthly satellite data were present, and we had interpolated and made two daily resolutions. And for feature engineering, of course, we created 21 input features including temporal lags for 1 day, 2 day, and 7 day, and rolling averages for 3 days, 7 days, and 14 days. And okay, so as you can see, all the data PM25 data satellite readings are present over here for whichever country, and we can also move the timeline to future past years. As you can see, I can move and see. Okay, we can animate this as well. Okay, talking about the data, we can upload a CSV file too from here, and we can also search for a specific city, and of course we can also manually type in the locations and the current values. See, if I run the forecast over here, see, health alert, air foster PM25 reached this, and you can see the point is over here. As you can see, it is pointing at this data 150, and for 72 hours 3 days, very unhealthy. So it predicts for the tomorrow, a day after, and 3 days forecasting. And of course the explainability factor is also given here, and we can save this scenario. We can also save the scenarios over here. We can also audit the logs. Audit logs are present over here. You can see the specs. We used XGBoost regressor. The model accuracy is around 0.979, and the inference time is less than 8 millisecond. And of course the training data which we have used is for 2050 to 2021, that is for 84 months. And of course for features, 24 input dimensions we have put. Yes, we can change the viewer options. Now let us talk about evaluation mode. Yes, if you want to evaluate, we can manually evaluate all the data present over here, and we can add whatever the cues you want. We can also upload CSVs, and it will actually predict the data. So this is our project, and yes, our approach was to actually bypass the need for ground stations entirely by satellite derived atmospheric data from NASA and ECMWF that is available globally. But and we have trained the machine learning models. I have trained a machine learning model on the 84 months data, and actually we can predict the 24, 48, and 72 hours into future of any coordinate on Earth. Thank you.